Hi guys! In a previous video we looked at how to add a ragdoll effect to our game. While this works, we didn't spend any time refining the ragdoll to make it look as good as possible. For example, we can see here that the limbs of the zombie are hovering above the ground. This is the first thing we're going to fix. We'll pick up from where we ended the previous video. If you haven't seen that one yet, then it might be best to take a look at that one first. Alternatively, you can download this project by supporting us on Patreon. All the relevant links can be found in the description. We'll delete all but one zombie for now so that we can focus on getting everything right. To fix the hovering limbs, we need to modify the colliders that we set up last time. If we select the hip bone in the hierarchy, we can see the current state of the colliders. Some of them are much too large, and that's why we're getting the floating effect. Let's start by changing the collider on the left upper leg. We'll just play about with the radius until it fits the model as best it can. Once we're happy, we'll select the three dots menu on the collider and select Copy Component. Then we'll select the right upper leg. Now we can click the menu on the collider and paste the values so that it matches the left leg. Next, we just need to do the same for all the colliders, resizing and lining up with the model as close as possible. Okay, let's give this a try. We'll just shoot him in the leg. Now we can see that the limbs are lying flat against the ground. But we have a problem with the feet clipping through the ground. This is because we haven't got any colliders covering the feet yet. Let's stop the game to fix this. We'll select the left leg in the hierarchy to see which components we need to add to the feet. We can see there is a rigid body, which has some physics settings such as the mass of the body part. Then we have a collider which determines the bounds of the body part. Finally, we have a character joint, which allows us to set which body part this one is connected to, and other properties such as the angular limits of the joint. Let's set this up for the feet. We'll select the left foot in the hierarchy. Then we'll add a character joint component. This automatically adds a rigid body component. Then we need to add a collider. The obvious choice for the foot is a capsule collider. Unfortunately, we can't line this up because of the angle of the foot bone. Instead, we'll split the foot into two joints, one for the ankle and one for the base of the foot. We'll delete the capsule collider and add a sphere collider instead. We'll scale this down and line it up with the ankle. Next, we need to configure the character joint for the ankle. To help us do this, we'll copy the settings from the left leg. We'll right-click the joint component and select Copy Component. Then we'll go back to the left foot and right-click to paste the values in. That gives us a good starting point, but we need to change a couple of things. We'll drag the left leg into the connected body field to join the foot to the leg. Then we'll select this icon to edit the angular limits. This lets us control how much the foot can rotate. We don't want to allow angles that are too extreme, as it can look like the foot has become dislocated. It can take a bit of trial and error to get this just right. That should be good. Next, we'll add another joint for the left toe base. This time, the angle of the bone does allow us to add a capsule collider. We'll scale and position this over the foot. OK, now that's done, we'll copy and paste the character joint values from the left foot joint. We need to change the connected body to the left foot. Then, for the angular limits, we don't want the base of the foot to bend very much, so we'll reduce the range right down. And that's it for the left foot. Now we just need to repeat the process for the right foot. We'll copy the joint values from the left foot so that all the settings are the same. We just need to remember to update the connected body to be the equivalent on the right side. OK, let's press play to try this out. We'll trigger the ragdoll again. Now the feet are part of the ragdoll physics and look much better. The next improvement we're going to look at is the use of physic materials. Physic materials allow us to control various physics settings for a collider, such as friction. We'll go to the Assets panel and add a new physic material. We'll call this Ragdoll Physics. These are the default physics values that the ragdoll is using at the moment. We'll reduce the friction slightly so that the limbs are less likely to get stuck in awkward positions. Then we'll go through and drag the material onto each collider. We'll press play to try this out. The difference is subtle, so you may not be able to notice too much difference. Let's stop the game and do something a bit more extreme. We'll set the friction to 0 and set friction combined to minimum. This is saying that the friction will always be 0, regardless of the friction value of the item it's colliding with. Let's see how this behaves. Now the zombie slides off into the distance. This probably isn't what we want, but it demonstrates how we can use physic materials to change the behaviour of the ragdoll. We'll stop the game and set the values back to what they were before. Something else you may notice when testing the ragdoll physics is that sometimes some of the limbs manage to clip through the floor, like we see here with the arm. This is down to the collision detection mode of the colliders. By default, it's set to discrete. This is the most performant, but collisions are only checked at fixed updates, so sometimes you can end up with this issue. Let's stop the game and change the collision type to continuous for the arm colliders. This will detect collisions between fixed updates and will prevent the arms getting stuck in obstacles. We can do this for as many colliders as we need to, but the problem seems to mainly happen for the arms, so we'll leave it at that for now. The final thing we're going to improve from last time is in the script where we detect which rigid body has been hit. Here we're using a link statement to find the closest rigid body. While this works and is really convenient, someone rightly pointed out in the comments that this isn't the most performant. This is a good example of how we have to be more careful in our decisions when making games compared to other software development. Using link is completely fine if you're developing a web application, for example, but in games where every frame counts, it should be avoided. So instead, we'll create a method to find the rigid body that's been hit. We'll take the hit point as a parameter. In here, we'll create a local variable to keep track of the closest rigid body to the hit point. We'll set this to null initially. Then we'll add another float variable to track the closest distance. Next, we'll loop through all the rigid bodies. We'll calculate the distance of the rigid body from the hit point. Then we'll check if the closest rigid body variable is currently null, or the distance to this one is smaller than the previous closest distance. If either of these conditions are met, then we know we've found a closer rigid body and we'll set the two local variables. Once the loop is complete, we'll return the closest rigid body that we found. Then we'll replace the link statement with a call to this method. OK, let's save this and switch back to Unity to check everything still works. We'll shoot the zombie in the head. Excellent, the ragdoll responds as we would like. The next step in this series will be to reverse the ragdoll and have the zombie stand back up again. A bit like this. We'll walk through how we did this in a future video, but as a challenge, see if you can recreate it and let us know how you get on in the comments. OK, that covers everything for this video. A big thank you to all our patrons. We really appreciate you helping to support the channel. If you'd like to help and also get access to the source code, you can find details in the description. Please leave any questions or feedback in the comments, and subscribe and click the bell icon so you don't miss the next one. Thanks guys!